Now guys, many times we don't have direct quadratic equations. We have some applications of quadratic equations going on. So we'll see this question. Solve the following equations. The first question is a raised to 4 minus 2a square plus 1. What we do here is we substitute a square as equal to y, right? So now the question simply changes to, okay, we are substituting a square equal to y. The question changes to a raised to 4 kya ho jayega? Y square minus 2y plus 1 is equal to 0. This is again a square minus 2ab plus b square is equal to 0, right? This is a minus b the whole square expansion, right? So y is equal to nothing but 1 or 1 repeated roots. But हमने substitute किया a square as y, right? So we resubstitute a square as y. So a square is 1 and a square is 1. Okay, so you will get a as taking square roots plus or minus 1. Here also you will get plus or minus 1. Okay, we have repeated roots here. Okay, solve x square plus 8x plus 6. Now let's try to find out two numbers in sum 8 hai and product 6 hai. Don't exist, right? So many times we won't be able to factorize a given quadratic equation. Okay guys, when that happens, we have something called as the quadratic formula. Okay, for any quadratic equation ax square plus bx plus c is equal to 0, the quadratic formula gives you the value of x, the roots, that is minus b plus or minus root of b square minus 4ac upon 2a. So when you can factorize, no need to use the formula, but when you can't factorize, you can always go with the formula. Okay, so putting in the values, if you compare this equation x square plus 8x plus 6 equal to 0 with ax square plus bx plus c is equal to 0, you'll find out that a is 1, b is 8 and c is plus 6. Okay, putting the values in the formula, you will have x as minus 8, okay, plus or minus root of a square minus 4 into a into 6 upon 2 into 1, 2a, right? So if you simplify this further, you will have x as minus 4 plus or minus root 10. That's the required answer. Now we studied the quadratic formula, guys, and we saw that the value of the root x is minus b plus or minus root of b square minus 4ac upon 2a, right? Okay. Now, guys, when we plug in the values of a, b, and c from the equation, okay, many times if suppose b square minus 4ac is a perfect square, the root sign will get eliminated, right? Okay, so in that case, there will be no root sign. The roots will be rational in that case. But suppose b square minus 4ac is not a perfect square. Okay, the roots will consist of the square root sign. Okay, they'll be irrational in nature. Okay, if b square minus 4ac becomes 0, then the root of b square minus 4 is this term altogether is eliminated, right? In that case, there's only one root minus b by 2a. Okay, and guys, the last possibility, if suppose b square minus 4ac comes out to be negative, if this entire thing is negative, root of a negative number is imaginary, right? So we realize that the nature of the roots is determined by this b square minus 4ac ka term, right? That is, the roots are dependent on b square minus 4ac, the discriminant. Okay, and if the discriminant is positive, we have two possibilities. If it is a perfect square, the roots are rational and distinct. Okay, we can take the example of x square plus 5x minus 6, where the roots were rational and distinct. Okay, if the value of discriminant or delta is positive but not a perfect square, the roots are irrational and they will be conjugates, like x square minus 3 example, right? If the roots are real and equal, that is when delta or discriminant is equal to 0. Okay, that is, the root is minus b by 2a in that case. Directly you can say that. Okay, and if the value of delta is less than 0, the roots are imaginary and they will be basically conjugate. So x square plus 4 is that kind of an equation. Find the value of m such that the equation 4x square minus mx plus 9 equals to 0 has real and equal roots. I want you to pause the video and try it out for yourself, and then you can see the solution. Okay, so if you compare, the value of a here is 4. Okay, b here is minus m and c here is 9. So b square minus 4ac क्या हो जाएगा? Minus m b square minus 4 into a is 4 and b c is 9. So b square minus 4ac is minus m square minus 4 into 4 into 9 equal to 0. Okay, since the roots equation has real and equal roots, that means b square minus 4ac क्या हो जाएगा? 0 हो जाएगा. Okay, when you solve this, you get m square minus 44 is 0. So m equals to 12, right? No. Okay, that is the biggest mistake people make. Okay, m square minus 144 अगर 0 है, we can say this is m square minus 12 square equal to 0. It is a square minus b square, which is a plus b into a minus b, right? So m will take two values, plus or minus 12. Other way of looking at it is m square can be plus or minus 12, both the whole square. So m can be plus or minus 12 as such. So we talk about the roots now. Okay, we saw that from the quadratic formula, the roots were minus b plus minus root of b square minus 4ac upon 2a. तो plus and minus दोनों roots को हम separate करते हैं. Okay, the slightly more positive root we call it as alpha. Okay, and the slightly more negative root we call it as beta. Okay, so if you say I have written alpha and beta separately, I will separate the denominator 2a between the two terms now. Okay, now when I add these two terms, guys, the plus root of b square minus 4ac ka term and minus root of b square minus 4ac upon 2a ka term, they get cancelled out, right? Because they have opposite sign. So minus b upon 2a minus b upon 2a is minus 2b upon 2a. 2 cancel. You have sum of the roots as minus b by a. Okay, so always remember, guys, for any quadratic equation in the world, the sum of the roots is always equal to minus b divided by a. Okay, same thing you can observe for the product of the roots, guys. We can multiply alpha and beta. When you multiply, you will simply land up with alpha and beta equals to c by a. Okay, if you want to understand the derivation, I have given it here on the screen. You can just pause the video and check it out for yourself. Let's write the quadratic equation ax square plus bx plus c here. Okay, now I'll divide throughout by a. I'll get x square plus b by a into x plus c by a is equal to 0. But just now we saw that sum of the roots is minus b by a, right? And product of the roots is c by a. So here b by a I'll replace by minus alpha plus beta, and c by a is the product, okay, which is alpha beta. Okay, so now we have one more way or one more method of writing the equation of a quadratic, that is x square minus alpha plus beta into x, sum of the roots into x plus product is equal to 0. Okay, so always remember there is also one more way out to write the equation of the quadratic. It is x square minus the sum of the roots into x plus the product is equal to 0. Yes, and if you basically open this out, you will get x square minus alpha x minus beta x plus alpha beta. Okay, in the you can take alpha common, in the you can take basically beta common. Okay, just like normal factorizing, you get x minus alpha into x minus beta is equal to 0. So we have one more way, a third way of writing the equation of a quadratic, x minus alpha into x minus beta is equal to 0. Okay. Find the quadratic equation whose sum of the roots is 10 and the sum of the squares of the roots is 58. Okay. Now we have been given sum of the squares of the roots, alpha square plus beta square as 58. And we have been given the sum of the roots alpha beta as 10. What we do is we start by squaring this equation. When we do that, the left hand side will be alpha square plus beta square plus 2 alpha beta is equal to 10 square 100. But alpha square plus beta square we know from here is 58. So basically 58 plus 2 alpha beta is equal to 100. 100 minus 58 is 42. If 2 alpha beta is 42, that gives me alpha beta is 21. So we have sum of the roots 10. We have the product 21. Okay, we can find the equation or we can form the equation. X square minus sum into x plus the product is equal to 0. Okay, so x square minus 10x plus 21 is 0. Okay, if you can factorize, if you want to factorize, it's basically x minus 3 into x minus 7 is equal to 0. Okay, or you can keep it as it also, no problem. Okay, if you're slightly better with numbers, slightly good with numbers, you can observe that 58 is nothing but sum of the squares of 49 and 3. 49 and 9. 49 is 7 ka square and 9 is 3 ka square. What is 7 plus 3? 10. So clearly the roots of the equation are 7 and 3. Right? So you can make the equation very easily. X minus 7 and x minus 3 is equal to 0. See, it makes things very, very easy, right? Okay, let's go on to the next question, guys. Find A if the roots of the quadratic equation 7x square minus 4x plus 7 into 3p minus 1 is 0 are reciprocals. Okay. So guys, if the roots are reciprocals, मतलब अगर एक root alpha है, दूसरा root क्या हो जाएगा? 1 upon alpha, right? In that case, if you multiply these two roots, the product will be 1. So guys, always remember, whenever the roots of a quadratic equation are reciprocals, then the product of the roots is simply equal to 1. Okay. But we also know that for any quadratic, the product of the roots is c by a, isn't it? In this case, c is 7 into 3p minus 1 and a is 7. This is the value of c by a. Okay, this is equal to product of the roots, right? जो कि 1 होगा in this case. So cancel out 7. You get 3p minus 1 is 1. 3p equals to 2, or this gives you p is equal to 2 by 3. It's as simple as that.